All right, let's talk about grid computing. Now imagine you could harness the power of millions of computers scattered all across the globe, all working together to solve one single massive problem. It's an incredible idea, right? But it also comes with a security challenge that is just as massive.
I mean, really think about that for a second. We're not talking about locking down one server in your own data center. We're talking about creating a secure, stable system out of a huge, messy, distributed collection of computers that you have absolutely no control over. So how do you even begin? Well, let's start by breaking down the challenge itself.
So, what are the actual dangers we're looking at in a grid environment? To get a handle on the risks, we first need to be really clear on what we mean when we say grid.
Now, the most important part of that definition is that phrase, multiple administrative domains. See, we're not just connecting a bunch of computers. We're connecting entire organizations, universities, research labs, maybe even your home PC, and each one has its own rules, its own owners, and its own level of security. This is not some neat and tidy cluster. It's more like a global patchwork quilt of computing power.
And because these grids stretch across all those different boundaries, you just can't take trust for granted. You can't just assume that a machine in another country, run by some other organization, is secure or is even who it claims to be. This means trust isn't an add-on. It has to be built right into the very DNA of the grid's architecture.
When we look at the threats, they pretty much fall into four main buckets. First, you've got your classic bad guys, the intruders and thieves trying to break in or listen in on your data. But then you've got the internal problems. Things like user-made errors, where someone submits a bad job that messes things up, or just plain old machine failures where the hardware or software gives out. Any one of these can seriously compromise the entire grid.
So, that brings us to the very first line of defense. In this huge distributed network, how do you prove that someone or some program is who they say they are? This is all about authentication.
And right away, we have to make a key distinction, because not all grids are the same. On one hand, you have volunteer desktop grids. Think of projects like SETI at Home. Here, the main goal isn't really ironclad security. It's more about just tracking who's contributing what. So they use a simple account key, which honestly is pretty easy to steal. But on the other hand, you have these big institutional grids used for major scientific research. For them, security is everything, and they use much stronger methods, specifically something called a public key infrastructure, or PKI.
So how does this strong security actually work? Well, it all relies on something called a trust path. It starts with a certification authority, a CA, which is basically a super trusted organization that acts like a digital notary public. The CA issues a unique digital certificate to a user, which is kind of like their digital passport. But you don't want to show your main passport for every little thing you do, right? So for a specific job, the system creates a temporary delegated proxy certificate. This proxy acts on your behalf for just a little while, giving you secure access without you having to constantly flash your main credentials around.
Okay, great. So we figured out who the user is, but that's really only half the battle. Now, how do we protect the actual computers, the resources themselves from being hijacked or misused? It's time to fortify the grid.
Protecting a resource on the grid really comes down to some fundamental, almost common-sense security practices. You need properly set up firewalls, of course. You have to keep absolutely everything, your OS, your software, constantly updated. You use quotas to make sure no single user or job can hog all the resources. And this one is crucial. You use sandboxes, like virtual machines, to run programs in a totally isolated space so they can't do any harm to the host system. And finally, you monitor everything, all the time. And this monitoring isn't just a vague idea. It's done with some really powerful real-world tools. You've got things like Ganglia, which gives you that big picture, bird's-eye view of how thousands of machines are doing. Then there's Nagios, which is like the alarm system. It alerts the admins the second something goes wrong. And finally, you have tools like Tripwire, which acts like a digital security guard, constantly checking important system files to make sure an intruder hasn't tampered with them. You know, when you really boil it all down, security in these massive distributed systems isn't some feature you just install and forget about. It's a dynamic, ongoing process. It's a constant negotiation of trust between users, resources, and organizations that, at the end of the day, are all basically strangers to one another. And the challenges that grid computing is tackling today, figuring out identity across different domains, securing shared resources, building trust between strangers, these are really just a preview of the challenges that all of us are going to face as our world gets more and more interconnected. The solutions they're building today might just become the security standards we all live by tomorrow.
If you found this breakdown interesting, do me a favor and share it with your network. And of course, subscribe for more explainers like this one. Thanks for watching.